Hello everyone. In today's lesson, we're going to be learning about how to factor a polynomial function using rational root test. So rational root test, it starts with what we call the polynomial in a standard form. So a polynomial in the standard form, what does it look like? It looks like from the highest exponent of x to the lowest exponent or the constant term. So in the example that I have down here, you can see what an example of a standard form of a polynomial looks like. X to the fourth minus 4x cubed minus x squared plus 16x minus 12. So this polynomial is in the standard form. So assuming that your polynomial is in standard form, or if it's not, you're going to go ahead and put it in the standard form, then you're going to be dealing with two numbers in this polynomial. The leading coefficient, which we're going to call it a sub n. In this example that I'm showing you here, that coefficient is 1, all right? And the other number is going to be a0, which is the constant term. So in this case, for me, that number is 12. So according to the rational root test, the possible rational roots. Now, what do rational roots mean? That means these roots can be written as fractions, as ratios. And for the purposes of this theorem, the polynomial we're going to be factoring will have only rational roots. So this test can actually give us all the roots of the polynomial, all the zeros of this polynomial. So we're going to go ahead and apply this idea in this example. So we know that the leading coefficient is 1 and the constant term is 12. And these are the factors of 12, 1, 2, 3, 4, 6, and 12. And the factors of 1 is just 1. So here in this case, the possible roots are going to be these values, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. The next step is to plug in these values, test them out, and see where we're going to get zeros. So for that, I'm going to go ahead and use the calculator. So here on Desmos, I put the standard form of the polynomial as we were given, and I'm actually plugging in these values, plus 1, negative 1, etc. So as you can see, at 1, we get 0. Then again, at 2, we get 0. At negative 2, we get 0. At plus 3, we get 0. And that's actually it. So if I plug them in for the other values, and those were actually the only zeros that we get, right? And for a polynomial of nth degree, so in this case, this is a polynomial of fourth degree. So the degree of the polynomial is the highest exponent of x that you have in that polynomial when you put it in the standard form. So when you have a polynomial of fourth degree, it can have a maximum of 4 rational roots, or 4 roots in general. That's the maximum number we can have. So here we have captured what all those roots are. Now, here we can actually test that. So I'm going to plot this function and I'm going to see where these zeros are at. So as you can see, the zeros of the function are located at negative 2 comma 0, 1 comma 0, 2 comma 0, and 3 comma 0. Now that I have the roots, I can actually write the factors. I can write this function in the factored form. So we can turn the roots into factors. So for plus 1, we get a factor that's x minus 1. When the root is plus 2, the factor is going to be x minus 2, because the idea is that you set each factor to 0 and you solve it for the root. So we're going to go the other way. We're going to start with the root and write the factor. So for x equals negative 2, the factor is going to be x plus 2. For x equals plus 3, the factor is going to be x minus 3. So at the end, we have this function as the factored form. F of x equals to parentheses x minus 1 times x minus 2 times x plus 2 times x minus 3. And if I plot this on Desmos, as we will do right now, you can see that's exactly the same function as we have in the standard form. This is just expressed in the factored form. Again, if I uncheck that and check that back in, you see that it's perfectly the same function. So this was a quick intro to what the rational root test is and how it can help us find the rational roots of the polynomial and use that to write the polynomial function in the factored form. Hopefully this lesson was helpful to you, and I thank you everyone for your attention. See you next time.